So we're going to start by looking at 1.3 part 2. So we talked a little bit about functions last time, and we said that if something is a function, it passes a certain test. What's the name of the test it passes? Yeah.
The vertical line test.
Right, the vertical line test. So let's draw this. This is going to be a function, which means it'll pass the vertical line test. And we're going to find the domain and the range. Okay, so we're going to practice domain and range a lot. So if you don't remember exactly how to do it or what that is, we'll go over it again right now. So find a complete graph. Remember, that means to find a window where the graph or the window shows everything that's kind of important about the graph. So I'm going to type in 16x minus x cubed and press graph. So if I can put that here. Okay. Now, if you look at the graph I have, does it look like that's a good window, or does it look like it goes off the screen a little bit? Yeah, it goes off the screen. So I think what we want to do is probably look a little bit lower and a little bit higher to see what we're looking at. If I want to set my window to go lower and higher, which two values would I adjust? The y max, yep.
How do you do the cube?
To do the cube, it's the button above the divided by sign, and then a 3. So it's, yep, it's that little up arrow. So what are the two things we have to adjust to see higher and lower?
The window.
Yeah, in the window, we're going to do the y min and max. So let's set the y min. Let's try like -40. And for y max, let's try +40. If it still goes off the screen, well, we'll do it even bigger. Okay, the x min and max, I just kept -10 to 10. Okay, now when I hit graph, yeah, I think that looks pretty good. So when you look at that graph, nothing else interesting is going to happen here. The left side is just going to keep dropping, and the left side is going to keep going up.
Yeah, the whole thing.
So left side keeps going up, right side keeps going down. But seeing this point and this point, that's what's important to make it a complete graph, because those are what we call it's like a minimum in that area and then a maximum over there. Okay, so find the domain and range. When we want to find domain, there's two things you have to be careful about. One of them is taking the square root of a negative. Is there a square root in this problem?
Yeah, no.
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 No. So no square root. Is there a fraction with a variable in the bottom?
No.
No. So the two things that you are not allowed to do don't happen in this one. So what do you think that means the domain is?
All real numbers.
Yeah, it's all real numbers. Another way to think about it is ask yourself, is there any number you can't raise to the 3rd power? No. You can cube any number you want. Is there any number you can't multiply by 16? No. You can multiply anything by 16. So there's no restriction on the domain. So does anyone remember how we write all real numbers?
ARN.
As like an interval. Yeah?
Would be plus infinity, comma, or minus infinity?
The other way. So you always put the low value first, then the high value. And then we have to put symbols around that. The two symbols are either brackets or parentheses. Bracket means you can reach the value. Parenthesis means you can't. So can you reach infinity?
No.
No. So that is how you write the domain. Okay, now the range. Domain is how far left and right the graph goes. That's another way to think about it. It might not look like it's going left and right forever, but it is. This part here is just going to keep going slowly further and further to the right. Range is up and down. How far up and down does it look like that graph goes?
Infinity.
Yeah, it's going to go, it does go up forever and it goes down forever, which makes the range the same thing. Usually the domain and range are not the same, but this time they are. So low value, high value, parentheses, meaning you can't reach them. If we can reach a number, then we'll use a bracket. Okay, now the last part, well, actually it was the first part, find a complete graph. So all we do is write down our mins and maxes. Take my window. And then just write down those values. This was a -10. And the y min and max. -40 to 40 is definitely not the only one you could use. But it's what we used. Any questions on that? Let's try. All right, let's try this one. Okay, so this problem is going to be about a swimming pool. And the pool is going to be rectangular. And the dimensions of the pool are 30 feet by 50 feet. And there's a sidewalk all the way around the pool. And the sidewalk is the same width all the way around. What we don't know is the width of the sidewalk. That's what they're going to have us find. But we do know the area. So the area of the sidewalk is 600 square feet. Find the width. Okay, so they give a lot of information here. What do you think would make this easier to visualize? Yeah, a diagram, right? We should really try to draw it out, kind of see what we're looking at, and then I think it'll help it make more sense. So first of all, I have a rectangular swimming pool. So let's start with that. So here's my rectangular pool. Put some water in there. There we go. So there's our pool. And the dimensions of the pool are 30 feet by 50 feet. Okay, so we've got 30. You know what? I'm going to put it inside because I need to put more stuff outside. So 30 by 50. And now I have a sidewalk going around the perimeter of the pool. Now, if the pool shape is a rectangle, the sidewalk that goes around the pool is also a rectangle. Because it says the sidewalk is the same width on every side. So there's your sidewalk. Okay, what we don't know is this. X. That's the width of the sidewalk. Okay, which is the same on every side. Bless you. All right, so they gave us a piece of information we haven't used yet. We used the dimensions of the rectangle. We marked the width of the sidewalk. What else did they give me that I haven't used? Yeah. The total area of the sidewalk. Okay, so let's see if we can come up with a formula that gives us the area of the sidewalk. So we've got two rectangles here. We've got the big rectangle, and then we've got the rectangle for the pool. Can anybody think of something you could do with the big rectangle and then the pool rectangle? And if you do this, what you'd be left with is the area around the edge. Yeah, Jake.
The area of the pool, and then subtract.
So subtract the area of the pool from
The area of the sidewalk.
Yeah, we know the area of the sidewalk. We're going to be able to fill a 600 in right here. But we do want to subtract the area of the pool from something. And then that would give us the area of the sidewalk shape. Yeah.
The total land?
Yeah, this we'll call this like this big rectangle. So if you can find the area of the big rectangle and then subtract the pool, you're going to be left with the area of the sidewalk. All right. Well, we know the area of the sidewalk. We can figure out the area of the pool. The area of the big rectangle. What's the formula for area of a rectangle? Base times height, or length times width, however you want to think of it. So we need the length and we need the width of the big rectangle. Oh.
30 feet.
Okay, so we got to find the length first. Do you think the length of the big rectangle is more than 50 or less than 50?
More.
Yeah, it's more. Okay, it's 50. That part's 50. From there to there. How wide is this part on the end?
We don't know.
We don't know, but how did we represent it?
X.
X. And how wide is this part on the end?
X.
That's the other end of the sidewalk. So what would be the total length of this, that, and that?
2x plus 50.
2x plus 50. Okay, so the length of the big rectangle is 2x plus 50. Now doing kind of the same thing, anyone think they could tell me the width of that, and that? Yeah.
It would be 30 plus 2x.
Yep, I'm just going to write it the same way. 2x plus 30. And there's the area of the big rectangle. The length is 50 plus 2x, and the width is 30 plus 2x. Now the other ones we can fill in. Area of the sidewalk, what did they tell us that was?
600 feet squared.
600. Now the area of the pool they didn't give us, but we can find it. We know the pool is 30 by 50. So that's 1,500. Okay, so now we have an equation where we're going to have to distribute that out or FOIL it, and then we will solve for x. So let's do it. And x is the width of the sidewalk. Okay, so we get 600 equals, and let's start with 2x times 2x. That gives me 4x squared. All right. Then we have 2x times 30. So I'm just going to put that off to the side for a second. So we get a 60x. And what's 50 times 2x?
100x.
100x. So how many x's altogether?
160.
160x. And then 50 times 30.
1500.
That's plus 1,500. Minus 1,500. So plus 1,500 minus 1,500. That's good. Okay, so now we've got 600 equals 4x squared plus 160x. So this is an equation where the highest exponent is a 2. If you were to graph it, it would be a parabola. Does anybody remember what type of equation this is called, where the highest exponent is a 2, begins with a Q?
Quadratic.
It's a quadratic. And whenever you want to solve a quadratic, the goal is to get everything on one side, and you can either factor it or use the quadratic formula. I don't think factoring is going to work in this case, so we're going to do the quadratic formula. So to get everything on one side, I think the easiest thing, bless you, would be to just subtract the 600. So that's going to give me 4x squared plus 160x minus 600. Now, you can use those numbers the way they are. Or, does anybody see something you could do to all the numbers and it would make them smaller? Yep, Jason.
Divide by 4.
Yeah, you can divide everything by 4. You do not have to. But if you do, it's going to be a little easier. So x squared. What's 160 divided by 4?
40.
40 minus 150. Okay, so here's the equation we have to solve. And the formula we're going to use is the quadratic equation. So this isn't really a whole lesson about how to use the formula. Hopefully you remember it a little bit. Does anybody remember how it starts? Yep.
X equals negative b plus or minus the square root of b squared minus 4ac, and then overdo it.
Perfect. Yep. Now, you mentioned 3 letters, A, B, and C. Can you tell me in our formula, what's A, B, and C?
A would be 1 right next to x squared is the coefficient.
Yep.
The b coefficient would be 40. And then c coefficient would be negative 150.
Perfect. Good job. Now, fill those numbers into the formula and see what we got. So we're going to have x equals negative b plus or minus b squared. Let's do that. What's 40 times 40? 1600. Good. Minus 4 times a times c, all divided by 2 times a is 2. Okay, so the last thing I'll do before we type this in is just simplify what's under the square root. Now, we're going to be subtracting a negative number. What happens when you minus a minus? Becomes a positive. So I might as well just make those positive right now. All right, so we have negative 40 plus or minus the square root of 4 times 150. 600 plus 1600. So 2200 divided by 2. Now we just have to type that in on the calculator and see what we get. Remember, we got to type it in twice because there's a plus and a minus. So we'll press second mode. It'll quit and get you back to the main screen. And then you can type negative 40 plus the square root of 2200. I like to do just that part first, so that's the top of the fraction. And then I divide it by 2 after. I'm doing it that way because I didn't use parentheses and I didn't want to go back and fix it. So when you type that in, you should get about 3.45. Yeah?
Why did the 4 change from negative to positive?
Because I'm subtracting a negative number.
Oh.
Because C was negative. Yeah. So now I'm going to switch over to say we get approximately 3.45 feet. How many people got 3.45 when we typed it in? Okay, that's good. Now let's type it in the other way. Negative 40 minus the square root of 2200. And then divide by 2. Negative 43.45. Now what are we trying to find here? X, which is the what? The width of the sidewalk. So what do you think about this number?
Would it be negative?
Yeah, you can't have negatives. So what that means is that the negative number is a solution to this equation algebraically. But it doesn't make sense in the word problem because negative values don't apply. So really, the only answer we get is 3.45 feet. Okay, so started out with the diagram, and then we ended up with a quadratic equation to solve. So you make sure you have that formula. If you don't, it's something you might want to put on your reference sheet for the test this week. Yeah.
Just as like a reminder, how do we know which ones are A, B, and C again?
So A is the number that's in front of x squared, B is in front of x, and C is the constant. Yes.
Is the test on Thursday or Friday?
I had a review day planned for Thursday, so we might start it Thursday and finish it Friday. I gotta double check the periods on Friday. But we're only doing 3 lessons this week, not 4. So I wanted to review Thursday a little bit. So we'll see.
Do you have tissues?
I don't. I only have those paper towels. Right in the back. Any questions on that? Yeah.
In the equation, I immediately just jumped out of my head that you got 2x plus 50 parentheses and plus parentheses 2x plus 3. How did you get that part of the equation exactly?
That was the length and the width of the big rectangle. So x and x for each end of the sidewalk, then the pool part, and then on the width, x and x for the sidewalk, and then this is the pool part.
Okay.
And then we added them.
Oh, so you just took two of the x's and just...
Because there's a sidewalk on each end of the pool.
Yeah, so you added that in to account for that, to add it as the whole...
The whole length. Yep. The length of the sidewalk.
Okay, that makes sense.
Yep.
Thank you.
You're welcome. Darren, let me double check that actually. I don't know how many lessons we're doing this week. That might be my other class. I gotta look.
Why did you just like
I'll double check in my email.
take away the part?
Because it's plus 1500 minus 1500.
Oh.
Yeah, the 1500s cancel out.
2 minus 2.
That's the reason.
Okay, so in the homework, I think there's a problem similar to that, but it says you have a photo and you're gonna put a border around the photo. It's the same thing as having a pool and putting a sidewalk around it. It's almost the same thing, just different numbers. Okay, so another thing that we look at in this section, which ties in with the kind of equation we just solved, the quadratic, is called projectile motion. So projectile motion is basically if you take an object and launch it, it kind of makes that shape. Or technically, even launching something straight up and have it come straight back down, you can still use this formula. So projectile motion is just the motion of an object that's been like launched.
Is that like S parentheses T or is that like?
Yeah, that's S of T.
Okay.
So S is the letter that our book uses. And we're going to go through what those letters mean. But this represents the height. So S sub T is the height. And if you launch something in projectile motion, you can find the height based on 3 things. So let me read the formula, and then I'll tell you what each thing is. So the formula is negative 16t squared. It's always a negative 16. That comes from physics. But then the rest of it, we have to fill numbers in. So negative 16t squared plus v sub 0 t plus s sub 0. A sub 0 on a variable means that it's like a start value or an initial value. It's like the beginning value. And in our case, v sub 0 means initial velocity. And s sub 0 is initial height. Because when you throw an object, you may already be standing on top of something. So like, let's say you're on top of like a building and you throw something. Well, it's still projectile motion, but it's started at a height of the building versus starting from the ground. This particular formula will only work if the problem is in feet and seconds, but we will always use units of feet and seconds. If you study something like this in physics, you might see the number negative 9.8 in front of t squared, and that would be meters per second. So it's a little bit different.
So the negative 16 is just gravity?
Yeah, it has to do with gravity. Yep, it has to do with gravity. So that number would change for different planets. Different planets would have a different number there. Right. So we're going to use that formula to figure out this question.
Are you a religious man?
Me?
Yeah.
I would consider myself so, yes.
Do you go to church on Sunday?
Do I go to church? Why are we asking me? So this particular problem is about a model rocket, and this one's going to be shot straight up. This is going to come straight back down. And it's being shot up from ground level with an initial velocity of 64 feet per second. So they tell us two things in that sentence that are important. What's one thing that they tell us that we're going to be able to use in that formula up above? Yeah?
Initial height.
Yes, they do tell us the initial height. What is the initial height? Ground level, 0. So the initial height is 0. And they also tell me the initial velocity is 64. So let's fill those numbers in. So the height equals negative 16t squared plus v sub 0 t, so my initial velocity times time, plus my initial height, but I don't need it this time because it's 0. So this equation is actually, it's very similar to the one we just solved. Got a number with something squared plus a number times that letter not squared. Let's go back to our equation. Okay, we've got a number with something squared plus a number times that letter not squared. So it's another quadratic equation. Okay, any question? I'm just setting this part. All right, now they want to know when will the rocket be 50 feet above the ground. So we have to figure out where that 50 would get plugged in. Okay, anyone think they know? Yeah?
The S of t.
S of t. Yeah, that's the height. That would replace what's right there. So then you'd have 50 equals, and then you have your quadratic equation. Like in the last problem, we had 600 equals. So we could now solve it exactly the same way we did the last one. I would say you could divide all the numbers by 2 and then use quadratic formula. But I'm going to show you how to do this one on the calculator. So let's try it a little different. instead of using quadratic formula. Okay, so what number would be on the left side? 50. So what we're going to do is we're going to put that number by itself on one line. And then on the next line down, we're going to put the other side of the equation. This is what's on the right side. Negative 16. Remember, you got to use x as your variable, not t. Now the blue one, y, that's like y equals 50. That's a horizontal line at what number? 50. So I need to set my y max to at least 50. I'd probably go to like 75. Do a little bit extra. Also, x is time. Does it make sense to have negative time? No, then don't even let x go negative. So let's go 0 to 10 on the x. Y is height. Can we have negative height? No, the lowest height that it can be at is 0. And the highest, well, we don't know the highest it goes. I'm just guessing 75. So I did 0 to 10 and 0 to 75. Okay, there's my line at 50. Actually, that's good. So what's in red, that represents the height of the object as time goes on. After 4 seconds, right here, the object has a height of 0, which means that it's back on the ground. So the object is in the air for 4 seconds. Do you think the object hits a height of 50 feet once or twice?
Twice.
Twice. Once on the way up, and then again on the way back down. Does anybody remember from last week, if you go to second calc, there's an option here we can use to figure this out. Yeah, it's the intersect. Did we talk about intersect last week?
Yes.
Okay. So I'm going to do the one on the left. Someone else can do the one on the right. So the first thing you have to do is put your cursor anywhere on the blue line. It doesn't matter. And just hit enter. Then put your cursor anywhere on the red parabola. Again, this doesn't matter where you put it. Put it wherever you want. And hit enter. Now the third thing it's going to ask you is the guess. The guess is what matters. Okay, I'm going to do the one on the left. Then if someone else can do the one on the right. Put your guess closer to the one that you want. Okay, I want the left one, so I put it on the left one. And then I hit enter. And I get 1.06. So that means that after 1.06 seconds on the way up, it'll hit 50 feet. Let's call that time 1. That's the first time. Okay. How about the second time?
2.93 seconds.
2.93. Anybody else get 2.93?
Yes.
Okay.
Yes, I did.
So projectile motion is really just another application of a quadratic formula. We didn't use quadratic formula. We used the calculator to see where they cross this time. We could have also done this with the area of the sidewalk problem. But I wanted to show you one way with quadratic formula and one way using the calculator. Any question on that? I think that one's a little easier than the sidewalk one, only because we didn't have to use quadratic. Yeah. Okay. So now it says, what is the maximum height and when is it reached? Well, we can also use the calculator to figure that out. You need to press second calc again. And I'm not going to do an intersect. What do you think I'm going to do this time to find the maximum height?
Maximum.
Maximum. Yep. Now, are we finding the maximum of the blue line or the red one? The red one. So right now, which graph am I on? The red one or the blue one? I'm on the blue. I'm not even on the right graph. If you press up and down, it'll switch which graph you're on. So I press the up arrow. And now to find the maximum, it's going to ask me 3 questions. Pick a point that you know is definitely to the left of your maximum. Pick a point that you know is definitely to the right of the maximum. And now do a guess that's pretty close to where you think the maximum is. Now, when you hit enter here, the calculator isn't going to be able to do algebra. All it can do is take a guess at what it thinks the answer is. So when I hit enter, I got 1.9999998. Depending on how you made your window, you might have gotten like 2.0000003. Anybody get something like that? Yeah. So we basically got the same answer. If we round it off, the maximum height occurs at what time? 2 seconds. And what is the maximum height? 64 feet. Yep. So max height is 64 feet. And this is at 2 seconds. So when you get a number that repeats with that many decimals staying the same, just round it off. And we can do that without a calculator. We're not right now, but you could. Any question on that? Okay, so last thing before we review slope. This part is more just on the calculator. It's graphing. But it's graphing what's called a piecewise function. So when you think of pieces, right, you think of multiple things, like pieces of cake. You don't think of the whole cake. You think of part of the cake. Well, that's what a piecewise function is. It's multiple functions drawn at the same time. And what we do is we divide the domain up. So, for example, let's say I had a formula to calculate ticket prices for an event. Maybe I have a formula that calculates ticket prices if you're under 18, and then I have a formula to calculate the ticket price if you're over 18. So which formula I plug into depends on your age. So if you said, okay, 15, all right, I plug into the formula for 18 and under. 39, I plug into the formula for 18 and older. So I have 2 different formulas to plug into, and my particular formula is split at the number 18. You could split it at any number. I just used 18 for like child tickets, adult tickets. And there's a different formula for each part. Maybe the formula for the child part is like y equals 15x. Where x is the number of child tickets you're buying or something, right? And then maybe the formula for the adult part is y equals 20x, where x is the number of adult tickets. So it's just 2 different prices depending on your age. What I want to show you how to do is type it in on the calculator and draw a picture. It's pretty similar to sketching anything we've sketched so far, but there is one thing that's a little different. Okay, so here's our 2 formulas. We have the formula 3 minus x squared, and then we have the formula x cubed minus 4x. If I said to you to find this, that means to plug 5 into the function and tell me the answer. Which one would you plug 5 into? The top formula or the bottom one? Yeah.
Would it be the bottom formula?
Right. Why the bottom one?
Because 5 is bigger than 1.
Right. The condition to use the bottom formula is if you have a number greater than or equal to 1. use the bottom formula. If you have a number less than 1, use the top formula. So like, what if I wanted to find exactly 1?
You can still use the bottom.
You still use the bottom formula. And you plug 1 in for x and then do it out. So it's just a formula and then a condition when to use the formula. Any question on the idea? And you can have more than 2. You could have 3 or 4 of them. But you can't have any overlap. Right? You can't have a choice like, oh, if you gave me the number 3, I could plug it into this one or this one. No. Every number has to have exactly one spot to go with the kind of piecewise functions we're doing. Otherwise, it wouldn't be a function. Yeah.
Isn't this the type of thing that like spreadsheets will do for you, like automatically or something?
You could probably set up a spreadsheet to do a graph like that. Yep. Or you could set up a spreadsheet to say use this formula under this condition, that formula under that condition. You definitely could do that.
Spreadsheets?
Yep.
What? You setting up spreadsheets now?
All right, so clear out anything you have typed in. All right, here's the difference. When we type in 3 minus x squared, we need to type it in parentheses. That's the first thing that's different. You're going to type 3 minus x squared in parentheses. The other thing you have to put next to it is the condition. When do you want the calculator to draw that picture? When x is less than 1. Put another parenthesis. Put an x. And now I have to show you where the less than sign is. Okay, the less than sign is under second math. In this case, we want the 5th one down. And then 1. Okay, let's do it again. Yeah?
Why do we have to use the x under length, or can we use the one if we get 2 from alpha? Are they the same or are they different?
Is what the same or different?
The 2 x's. Those are the same, right?
Oh, yeah, I think they're the same. Yeah, you can either press the X button or then alpha store. Yeah, I think you get the same thing. All right, let's do it again. So x cubed. Make sure after you type the cube, press the right arrow so you're not typing up in the exponent anymore, because I don't want the minus 4x up in the exponent. I want it. Nope, I want it just like that. X cubed minus 4x. And again, we need to put the condition in. When x, second math. This time we want option 4. So that's how you type in a piecewise function. Now, the calculator is going to do okay with it, but it's not going to do it perfect. So I'm going to show you what happens. We should not see a blue graph below the number 1. I mean, above the number 1. It should only draw the blue one when we are below 1. And we should only see the red one when we're above 1. It's not quite going to do that, but this is as good as we can do. Let's do zoom 6. So that's good. I should see the blue one. I should not see that part right there. Shouldn't be seeing that red part, but I should see that part. So the part that it draws along the axis, that shouldn't be there. There's no way to make it go away. That's as good as it can do it. So what I can do to just kind of fix it is I can just draw over that part. And that's what it should look like. Now, one more thing we have to put on it. Let's start with the blue one. When you get to the end of the blue graph, that's the 3 minus x squared. Do you include when you get to 1 on 3 minus x squared, or not include? Not include. And what type of circle do you use when it's not included? Open. So that tells me don't include the end of the blue. Now, when I'm at the beginning of the red, do I include the 1 or not include? Include. What kind of circle there? Closed. That is exactly how it should look. So the calculator does okay, gives you kind of a good starting point, but then you need to just fix these circles, and the part that's on the axis shouldn't be there. Because you should only see blue when you're less than 1. You shouldn't see it when you're bigger than 1. But that's a piecewise function, so it's like 2 different graphs pieced together. Any question? That's it for piecewise, just sketching piecewise. Okay, so the last part we'll do with the last half hour is just take a look at slope, y equals mx plus b. I'll go through it pretty quick since it's algebra 1, but I still want to just make sure people remember it. So slope intercept. Anyone remember? I think I already just said it. What's the equation for slope intercept? Yeah.
Y equals mx plus b.
Yep. Y equals mx plus b. And if you already know it, you don't necessarily need to write it, but it will be on the test. What's the m? Slope. And the b? Yeah, Brady.
Y-intercept.
Y-intercept. Now, anything that can be written in y equals mx plus b form is called a linear function. So you might look at something like this and say, well, that's not y equals mx plus b. But it could be. What would you have to do there to make that y equals mx plus b? Yep.
Would you divide the whole thing by 2?
Yeah, just divide everything by 2. There you go. So anything that can be rearranged to get y by itself and mx plus b on the right is called a linear function because it looks like a line. Yeah. Yep. Just a second. So any question on what a linear function is? That is not the only equation you can use. We'll talk about another one in a minute. It is one we use a lot, especially when we have to graph. So. Okay, so let's talk more about the m in the y equals mx plus b. Does anybody remember there's 2 words begin with r? We write them as a fraction. Yeah.
Rise over run.
Rise over run. Yeah. And if you want to find the rise between 2 points, like let's say you have a point here and a point here. Let's call this point x1, y1, and this point up here, x2, y2. How would you find that dotted distance that I just drew? That's called the rise between the points. Yep.
Y2 minus y1.
Y2 minus y1. And how would you find the run? That's the horizontal distance between the points. Yeah.
Y2 minus y1.
That's the rise.
Oh, x2 minus x1.
X2 minus x1. Yeah. So that's the formula to find the slope between 2 points. You find the difference between the y values. You put that on top. That's the rise. Rise goes with y's. Rise, y's. And then run is in the bottom. That's how you find your slope. So there are 2 lines with special slopes, horizontal and vertical. Horizontal and vertical lines are not in y equals mx plus b. They are special cases. Does anybody remember what the slope of a horizontal line is? Yep, great. 0. And how about the slope of a vertical line, Jamie?
Undefined.
That's undefined. Yep. And just to put this next to it, horizontal lines, well, we can draw horizontal lines. We did one on the calculator when we did the rocket hitting a height of 50. When we drew a horizontal line at 50, what letter was on the left side? Y. So y equals 50. That's how you draw a horizontal line. How about when you want to draw a vertical line? What letter do you put on the left?
X.
X. Okay, so these are special cases. We cannot draw vertical lines on the calculator. The calculator can only do horizontal, and then it can do slanted, but it can't do vertical. Because vertical lines fail the vertical line test, and the calculator can only draw things that pass the vertical line test. So let's see if we can find two lines, one horizontal and one vertical, that go through the point 2, 3. I already gave you guys this part at the bottom. Horizontal line is y equals a number, vertical is x equals. We just wrote that down on the other page. So 2, 3. Let's start with the horizontal. Horizontal line always has what letter on the left? Y equals. And then we put the number that we want it to go through. So what would be the equation of that line? Yeah, y equals 3. That's the horizontal line that goes through the point 2, 3. How about this line? X equals 2. That's a vertical line through the number 2. Again, horizontal, vertical, special cases. They are not y equals mx plus b. Any question on that? Listen. Okay, so here's another one that is not in y equals mx plus b. 2x plus 3y equals 6. Can someone tell me what the first step would be to get this in y equals mx plus b? Just the first step. Ready?
I would subtract 2x on both sides.
Yep, subtract the 2x. So that's going to give you negative 2x plus 6 on the right. It's still not quite y equals mx plus b. It's better. Anyone give me the last step?
Divide by 3.
Yep, divide everything by 3. And there you go. And you could fix that up a little bit. You could do 6 divided by 3 and put 2. But why would you want to do that? What's the advantage to getting y by itself? What would it make it easier to do now? Yeah.
Solve the rest of the equation.
Okay, so if you had a number for x, you could plug that in and then multiply by negative 2/3 and add 2. What else would it make easier to do? Yeah. Yeah, it would make it very easy to graph now because you can see the y-intercept and you can see the slope. Down 2, right 3. That's why we get it in y equals mx plus b. It generally makes it easier to graph. That's it. Any questions on that one? Okay, so now I'm going quick through the y equals mx plus b, but hopefully there's nothing new here you haven't seen before.
I missed the previous slide. Can you go back?
The previous slide?
Yeah.
This part, the horizontal and vertical, it was the y equals 3 and x equals 2.
Oh, okay. Never mind.
Oh, you got it?
Yeah.
Oh, okay. Yeah, that's all that was on it. Okay, so point slope. This is another way to write the equation of a line. And it's exactly what it says. It's a point and a slope. So to write an equation in point slope, it's y minus y1 equals m times x minus x1. When you write the equation, you need to fill in for three things. The y1, the m, and the x1. The y, the equals, the parentheses, the x, you don't change any of those. Just plug three numbers into the three spots I highlighted in green. Let's try an example. So this is something that's on the test. Find an equation of a line with a slope of a half, and it has to pass through the point -2, 3. So first thing we want to do is label these numbers so we know the spots they're going to go. How about Ethan? What's the 1/2?
The slope.
Yep. And which letter is that going to be in the formula?
That's going to be the M.
That's my M. Okay, so we'll plug that in for M. Landon, what about the -2? What letter? Where's that go?
X1.
Yep, that's my X1. And how about Ella? What's the 3? That's my Y1. Okay, so now plug those three numbers in and see what you get. So y minus y1 equals m times, now be careful with this, it's x minus x1. It's going to be x minus 2. So what's going to happen there?
X plus 2.
It's going to become an x plus 2. And that is the equation of the line in point slope. Now, if they said, okay, go one more step and make it y equals mx plus b, what's the first thing you do on the right side? Yep, you distribute out that 1/2. And what's the last thing you do? Plus 3. So what would this be in y equals mx plus b?
Equals 1/2 x plus 4.
Yep. So what's in the boxes are exactly the same answers. It's just a matter if they want point slope or slope intercept. Okay, any questions on that one? All right, last two things. So this is on parallel and perpendicular. And if two lines are parallel, then that means something about them. If two lines are parallel, they would have the same slope, but different y-intercepts. If you have two lines with the same slope, same intercept, then they're the same line. So two lines are parallel if they have the same slope and different y-intercepts. Where we're going with this is I'm going to ask you to find an equation either parallel to something in a second or perpendicular to something. But as long as you know the connection about the slope, it's very easy to do. So parallel has the same slope and different y-intercept. Perpendicular, it's a little different. Does anyone remember if two lines are perpendicular, what the connection is between their slopes? Aaron?
Reversed.
What do you mean reversed?
Like they're the opposite of each other. Like what the numerator is negative in one, the numerator is positive in the other. But they're the same numbers, same absolute values.
Okay, I agree that they are opposites. One of them is a positive, one of them is a negative. But there's actually another piece to it. So they are opposites. Yep.
The slope of one line is the opposite reciprocal slope of the other line.
Right. They're opposite reciprocals. So what that means is if you had a line with a slope of like 2/3, what's the opposite reciprocal of 2/3? Yeah.
-3/2.
-3/2. Okay, so 2/3, the opposite reciprocal, is -3/2. Zach, could you just make sure if you want to write something down, just not to take a picture while class is going on? Okay, thank you. And it'll be on YouTube too. Okay, so let's try this.
Oh, so is me asking you if you're religious or on YouTube too?
Uh-huh.
You asking me questions also.
So write an equation on a line that's parallel and goes through a point. I could have done parallel or I could have done perpendicular. Either way. So if I want to be parallel to this, what's the first thing that I have to know about the line that's in that box? I have to know the slope. I don't know what I'm parallel. I can't be parallel to something unless I know what the slope is of that. Okay, so I need to find the slope. Okay, so let's just copy that down. 3x minus 2y equals 1. And Sean, what would be my first step to get y by itself there?
Bring 3x over to the other side.
Okay, and bring it over, and how would you do that?
Cancel it out by subtracting 3x on one side, subtracting on the other.
Perfect. So subtract 3x from both sides. So the number with x, is the slope -3? Slope is the number with x. Why not? What's wrong? Yeah, what's wrong here? Yeah. Yeah.
Oh, you have to get y by itself, so you divide both sides by -2.
Right, so Savannah just said you still going to get y by itself. So you have to still divide by -2. I can kind of stop at this point because all I'm interested in is the slope. What is the slope of this line? 3/2. And if I want to create another line that's parallel to that one, what will the slope of that line be? It has to be the same thing. So the slope of the new line is 3/2. The value that the new line has to go through is 1, -2. So now, plug in 3/2 for m, 1 for x1, and -2 for y1. Okay, I'm not going to go through that part, but you just fill those three numbers in, just like we filled in the three numbers in this problem right here. They're just different numbers, but it's the same formula. You've got the m, the x1, and the y1. You've got the m, the x1, and the y1. The key is making sure you could figure out that slope. Parallel versus perpendicular. Okay, any questions on that? All right, so last thing. So drawing an inequality. So this is where you draw a line. It can either be a solid or a dotted line, and you shade above or shade below. People remember that? Okay. So it's pretty easy when you have to figure out when to shade above or below, and whether you use a solid or a dotted line, if you just write down that chart. So you start by drawing your line. So let's say you had, we'll do something like y is less than or equal to 2x plus 3. Well, the first thing I do is I graph y equals 2x plus 3. And then I would make the line solid because it has the equal to symbol. Anytime you have a less than or equal to, greater than or equal to, solid. If it's a less than, you shade below. If it's a greater than, you shade above. And let's do that one. Y is less than 2x plus 3. And that'll be our last one. Bless you. Okay, so when you're graphing a line, what's the first thing you look at? The slope or the y-intercept? Yep, y-intercept. This one has a y-intercept. I'm just going to write this right here. Graph. What's the y-intercept on that one? 3. So where would I put a dot for the y-intercept? Yep. Positive 3. How do I get there?
You go origin up 3 squared.
Up 3, yep. And now my slope is what?
208.
Yeah, you want to think of it as a fraction. And 2 over 1 tells me from the y-intercept to go which way? Yep, up.
Up to right 1.
Up to right 1. Do it a couple times. And now, would this be solid or dotted? Solid. So let's draw, I need to fix that, solid line. And now, would we shade under the line or shade above the line?
Below.
Below, right? You're going to shade underneath. So when you shade, generally what I do is I just go like this. On Edge Elastic, what you'll do, you'll just click and you'll leave the color in the bottom or the top. And that's how you graph a linear inequality.
Any question on? I just have a question.
The homework? Yes. Okay, so the first part, that's on the functions and drawing piecewise functions, stuff like that. And then the questions on page 42, that's on slope, y-intercept, graphing inequality, shading above, shading below. And we will 32 to 36, yeah. And we will take a look at that tomorrow.